Okay, so how can you fill this out? Little bit and a lot? Did you guys like that? The numbers? So what are the numbers that go in for the x's and y typically? So 0 and 1, we can do those first. So this one over here, the middle would be 0, 0. If we go over this way, what would this one be? 1, 0. Okay, what would this one be? 0, 1. How about this one? Negative 1, 0. How about this one down here? 0, negative 1. Pay close attention because I'm going to make you guys fill one out at the end of the period. Okay? So you're not for like, I'm not quizzing you. Goodness gracious. We're going to... You guys were like, I heard she's evil, but now it's confirmed. No. To practice before it actually matters. See? See what I did there? Okay. Went from a bad teacher to a good teacher in about 30 seconds. Okay, so 1, 0. And then what are the other numbers that fill in the rest? We got 3 fractions. 1/2, root 2 over 2, root 3 over 2. Okay, so this first one goes to the right a lot, up a little bit. Okay, this one goes over and up the exact same amount. Root 2 over 2 and root 2 over 2. This one goes over a little bit, up a lot. Okay. This one goes left a little bit, up a lot. Negative, yep, because it went left. Negative 1/2 for a little bit. Root 3 over 2 for a lot. Left and up the exact same amount. Negative root 2 over 2 and positive root 2 over 2. Okay, this one went left a lot, up a little bit. Negative root 3 over 2 and 1/2. Ah, it starts to hit you, huh? Okay, let's pause on those. Let's start filling out some of the degrees and radians so we don't get bored of that stuff. Okay, so can we do the degrees? We got those? So this one's 0. What's this one? 30. 45. 120. 135. 180. 210. 225. 240. 270. Yep. 330. Okay. All right, how do we do the radians? How do we do radians? What do we have to know to do radians? What do we have to be good at? Fractions. Okay, so we've got 0 pi to start. What fraction goes right here? Pi over 2. Okay, what fraction goes right here? Pi. What fraction goes right here? Okay, and then what fraction goes over here? 2 pi. Okay. All right, so from here to here we have 1, right? And this is 1/2. So if I cut the 1/2 in half, what fraction is that? A fourth. So we have 1/4, 2/4, right? Is 2/4 the same as 1/2? Yes. Okay, what should be here? 3/4. What would be right here? 4/4, which is what we have. What goes right here? 5/4. What goes right here? 6/4, then 7/4, then 8/4 we're done. Okay. Now, if this is 1 and I have one little chunk here, and one little chunk here, and one little chunk here, and here, and here, and here, how many chunks was that? 6. Okay, so we're going to count by 6. We've got 1/6, 2/6, which is 1/3, and then 3/6, right, which is 1/2, and then 4/6, which is 2/3, and then 5/6, which we'll write down, and then 6/6, which is 1, and then what happens next? And then Trevor, what happens next? So 8/6, which is 4/3. And then what's this one? 9/6, and then 10/6, which is 5/3, and then 11/6. Okay, let's do the rest of the x's and y's. So this one is left a lot, down a little bit. Left a lot, down a little bit. Negative root 3 over 2, and negative 1/2. So left and down the same amount. Negative root 2 over 2, negative root 2 over 2. Left a little bit, down a lot. Negative root 3 over 2, okay. Right a little bit, down a lot. 1/2, negative root 3 over 2. Right and down the same amount. Root 2 over 2, negative root 2 over 2, and then what's the last one? And then negative 1 over 2. Okay, so what I just walked you through, that's how I have it memorized. That's exactly how I have it memorized, okay? All right, so if we think about what the x-coordinate means and what the y-coordinate means, what can I find if I'm using the x-coordinate? Cos of the angle, so whatever angle I give you, if I ask for cos of that angle, I just look at the x value. What's the y-coordinate represent? Sine, so sine theta. How do I find tan? I do sine over cos, aka y divided by x, okay? How do I find cosecant? Yeah, I take the sine and I flip it. So if I want cosecant, I take sine, I flip it. What about secant? I take cos and I flip it, so it's 1 over cos, which is the same thing as flipping the cos. How do I find cotangent? 1 over tan, which is the same thing as taking tan and flipping it. Okay, I need you guys to nose goes in your groups and have the person who lost has to go grab whiteboards for each person in the group. Hello. Oh. Uh-huh. I mean, it is. It's from last semester. Okay, first one.
Are these new markers?
Yeah, well, yeah, for the most part. First one is cos of pi thirds. Cos of pi thirds. Don't say it, just write it. Cos of pi thirds. Yes? I can't read that. You gotta make it bigger. I'm blind. Yes, I think. Yes. 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 All right, so with cos, we always look at the x-coordinate. So first we have to locate pi thirds. And then we see, ooh, the x-coordinate is 1/2. So I could write cos of pi thirds equals 1/2. Or you could just write 1/2, but you cannot write cos 1/2 because that's technically wrong. Okay, number 2. we are going to do sine of 2 pi thirds. Sine of 2 pi thirds. Yes, yes, yes. Yes, yes. No. Yes, yes. Yes, yes. All right, sine. Sine of 2 pi thirds would be the y coordinate, root 3 over 2. Sine of 2 pi thirds is the y coordinate. All right, next one. You're going to have to show some work for this one. This one is tan of 7 pi fourths. Tan of 7 pi fourths. Yes. Yes. So we have to do y. Yes. 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 So we have to do y divided by x. So if you look at 7 pi fourths, we have the y coordinate is negative root 2 over 2. The x coordinate is root 2 over 2. So we have y divided by x. And then what do we do from here? Keep, change, flip. Keep it, change it, flip it, because we have a fraction divided by a fraction. So we have negative root 2 over 2 times 2 over root 2. And then what happens when we do that? They cancel. So the 2 cancels with the 2. What does it leave behind? When things cancel, they divide to make 1. So it leaves a 1 behind. And then what do we do with the root 2's? They cancel. What does it leave behind? A 1. So we have negative of 1, which is negative 1. Okay? The way that we can tell that tan at this value is a 1 is that you have the same number divided by itself. The same number divided by itself makes negative 1. All right, number 4. All right, for this one, we're going to do sine of 11 pi over 6. Sine of 11 pi over 6. Yes, 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 yes. So we look at 11 pi over 6. We look at the y coordinate because this is sine, and we should have got negative 1/2. All right, 5th problem. We are going to do cosecant of 7 pi over 6. Cosecant of 7 pi over 6, but simplify it. So you can think 1 over sine, yes, or you can do the flipped version of sine. The flipped version of sine would be easier. So take sine and flip it. Close. Yes. 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 No. Yes. No. Yes. Yes, yes. You guys got to write real big. Yes. 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 That's okay. All right. So if we look at sine of 7 pi 6, sine of 7 pi 6 is negative 1/2. So to find cosecant of 7 pi 6, we just take that fraction and we flip it. We got negative 2 over 1. All right. Here's the next one, number 6. Maya, you're going to take a desk out in the hall because you're doing your request today. All right. Number 6, we're going to do tangent of 2 pi thirds. Tangent of 2 pi thirds. Real quick for the video, let's make sure we got this one right. So 2 pi thirds would be y divided by x. So we have root 3 over 2 divided by negative 1 over 2. And so how do we finish that? Keep, change, flip. The 2's cancel, and we end up getting root 3 over negative 1. And what is that actually? It's negative root 3. Okay. Yeah. We can do a cotangent. All right, let's do cotangent of pi. Cotangent of pi. So instead of y divided by x, you're going to do x divided by y. Instead of y divided by x, you're going to do x divided by y. Yes, you killed an Arctic fox. No. You killed an Arctic fox too. Yes. Yes. You killed an Arctic fox. Yes. Yes, yes. 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 That's not wrong, but you're not done. Yes. Yes. All right, so what should we have gotten and why? We should have gotten undefined because when we do x divided by y, we have negative 1 divided by 0. And can you do negative 1 divided by 0? No, so this is undefined. Okay, I need somebody to look up there where the Arctic foxes are in Mark 3. We killed 3 of them that round. 3 baby Arctic foxes died during that round. All right, here's the next one. We're going to do secant. Secant of 3 pi fourths. This one is going to take a little bit of work. Secant of 3 pi fourths. So you take your cos and you flip it. You take your cos and you flip it. And then you gotta fix it. So flip it and then fix it. Yes. Yes. No, wait. Hold on. Hold on. Hold on. 3. No, so it's not that. No. You guys are flipping the wrong one. Take your cos and flip it. Take your cos and flip it. You kind of started simplifying it correctly. Yeah, let's do this one together. All right, so what is cos of 3 pi fourths? Negative root 2 over 2, right? So for secant, we're going to do 2 over negative root 2. And are we allowed to keep a radical on the bottom? No, so how do we fix that? You multiply by root 2 over root 2. And so on the top, we have 2 times the square root of 2. On the bottom, we have a negative. And then we have root 2 times root 2. What's root 2 times root 2? Yeah, so you could say it's the square root of 2, and then that's being squared. What happens to a root that's been squared? It cancels. Okay, so we have 2 square root 2 over negative 2. Sorry, there we go. We have 2 square root 2 over negative 2, and that's because I had the negative in the front, and then the square root and the squared canceled, right? And what happens here? The 2's cancel. So this is just negative root 2. So secant of 3 pi fourths is just negative root 2. I'm going to give you another one like that, okay? So number 9, we're going to have another one very similar to that, okay? All right, so for this one, we're going to do secant again, and we're going to do secant of 11 pi over 6. Secant of 11 pi over 6. It's going to be similar, but not exactly the same. Secant of 11 pi over 6. Secant of 11 pi over 6. Yes. Close. Yes. No. Yes. Yes. So we're starting with this, right? But it's not fixed, right? You got to simplify it. Not over 1. So we have 2 over root 3, right? And we got to fix it. How do we fix it? We multiply it by root 3 over root 3. So on the top we have 2 square root 3. What do we have on the bottom? 3, right? The square root of 3 times the square root of 3. Yep, and so you would just get 3. And then that's it. You can't simplify any more than that. Last time we had a 2 on the bottom, so we would have canceled out the 2's, but this time we don't have a 2 on the bottom, we have a 3 on the bottom. Okay, so secant of 11 pi 6 is 2 root 3 over 3. All right, number 10. Yeah, for this one, we're going to do secant. I'm just really enjoying the secants. We're going to do secant of pi. Secant of pi. Secant of pi. Yes. Yes. The work is wrong? The answer is right, but the work was wrong? Yes. 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 The one on the bottom, yes. 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 So it felt like a trick, right? Because cos of pi, what's cos of pi? Yeah, cos of pi is -1. And if we think of the fraction, if we think of -1 as a fraction, it would just be -1 over 1, right? And so if we flip it for secant, then we're going to have 1 over -1, which is still -1. So cos of pi is -1, secant of pi is -1. They're both -1. All right, number 11. For this one, we're going to do sine of 11 pi over 6. Sine of 11 pi over 6. Yes. 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 Is that your negative? That like whole big blue thing? Yes. Yeah, that's good. I like. No. So if we look at 11 pi over 6 and we look at the y-coordinate for sine, we can see that the y-coordinate is -1/2. So it is -1/2. All right, number 12. All right, for the next one, we're going to do cos of 7 pi over 6. Cos of 7 pi over 6. Yes, yes, yes. Close. Yes, yes. Close. Tammy, you were close. Yes, 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 yes. Yes.
It's just a big.
I got you. All right, so 7 pi 6, if we look at cos of 7 pi 6 is going to be -√2 over 2. So what's the x-coordinate? -√2. Sorry, -√3 over 2. All right. Number 13. Tan of 5 pi over 4. Tan of 5 pi over 4. Tan of 5 pi over 4. Yes. Yes. So if we look at 5 pi fourths, we have to do y divided by x. So we have negative root 2 over 2 divided by negative root 2 over 2. And we have the same number divided by itself. And it's a negative divided by a negative, so this should be positive 1. It's the exact same thing divided by itself. All right, number 14. I'm going to give you another tan one. We haven't done one like this yet, okay? So you're going to have to think through it. We're going to do tan of 5 pi over 6. Tan of 5 pi over 6. You're probably going to have to show your work on this one. Yes, but you're not done simplifying. Yes. No. Did we get these first two steps? You're close. Did we get these first two steps? So the 2's cancel, and I have 1 over negative square root 3. Am I supposed to leave a square root of 3 on the bottom? No. Are we okay with these first couple steps? So we have the y coordinate, which is 1/2, divided by the x coordinate, which is negative root 3 over 2. And we do keep it, change it, flip it, and the 2's cancel. And now we have to fix the square root of 3 on the bottom. So I'm going to multiply by square root of 3 on the top, and I'm going to multiply by square root of 3 on the bottom. And what do I get on the top? Positive square root of 3. What do I get on the bottom? Yeah, the negative stays, right? I keep a negative. Root 3 times root 3 is just 3. And so square root of 3 over 3 is my answer. Did you show your work like I show my work? All right, number 15. All right, 15, we're going to do tan of pi thirds. Tan of pi thirds. Tan of pi thirds. Yes. Yes, 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 yes. Yes, yes. 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 All right, so if we do y divided by x, then we keep it, change it, flip it, right? And the 2's cancel, and we just have root 3 over 1, which is just root 3. All right, here's the next one. We're going to do secant. Secant of pi over 4. 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 So, secant of pi 4, secant is the flipped, it's very close. Secant is the flipped version of cos, right? You're close. So, Laura, you shouldn't be canceling anything yet. You should just be multiplying. Yeah, and then your 2's cancel. There you go. Yeah. There you go. Yes. So we look at pi fourths. We look at the x coordinate because secant is the flipped version of cos. And so we flip cos. So we have 2 over square root 2. And then what do we have to do? Multiply by root 2 on top and root 2 on bottom. And so what do we have across the top? 2 square root 2. What do we have across the bottom? Root 2 times root 2 is 2. And the 2's cancel, and so we just get root 2. All right, number 17. Tell me what cotangent of 0 is. Cotangent of 0. Cotangent of 0. So if tan is y divided by x, then cotangent is x divided by y. Yes. 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 Yes, yes, yes. Yes. So if we do x divided by y, we get 1 divided by 0, which is undefined. And that time, not one baby Arctic fox died, so that's good. All right, 18. Sine of 7 pi fourths. Sine of 7 pi fourths. Yes. 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 I can't see yours, Brandon. Yes. 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 No, you just like didn't turn it towards me. Yeah, perfect. Yes. Yes. So at 7 pi fourths, we're looking at the y coordinate, which is negative root 2 over 2. Cos of pi halves. Cos of pi halves. Cos of pi halves. Yes. 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 All right, the x coordinate at pi halves is 0. All right, 20. Sine of pi. Sine of pi. Yes. 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 No. Yes. 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 I think. That was real small. Yes. Yes. What's sine of pi? 0. 21. Tangent of pi over 6. Tangent of pi over 6. Tangent of pi over 6. Yes. Very close. There should be a 1 on top. See how there's a 1 on top? Yes. Skylar, you gotta keep going. You gotta keep going, Isis. Yeah, no. You gotta keep going. Because you can't have a radical on the bottom. Can't have a radical on the bottom. Yes. 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 Yes.
Okay, this is.
Yes. Yes.
Wait, are you sure?
Yeah, I was looking at the wrong spot, but yes. 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 The other ones.
Okay.
So we have 1/2 divided by root 3 over 2. And so what do we do with this? Keep, change, flip. Keep it, change it, flip it. And then what do we see? Yeah, the 2's cancel and you get 1 over root 3, which you technically can't have. So how do you fix it? Times root 3 over root 3. And what does that give you? Yeah, so it's root 3 on top. And what's on the bottom? 3. Square root of 3 times the square root of 3 is just 3. All right, 22. All right, this one is going to be cosecant. Cosecant of 7 pi over 6. Cosecant of 7 pi over 6. Yes. Cosecant. Yes. Yes. Of 7 pi over 6. Yes. 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 Yeah. Yes, yes, yes. You're looking at the wrong spot. Yes. Yes. No, you're looking at the wrong spot. So cosecant is the flipped version of what? Sine. So at 7 pi 6, we're going to look at the y coordinate, and we're just going to flip it. So at 7 pi 6, if you look at your y coordinate, it's negative 1 over 2. If you flip that, that's 2 over negative 1. And what's 2 over negative 1? It's just negative 2. All right, 23. 23 is cotangent. Cotangent of 3 pi fourths. Cotangent of 3 pi fourths. Very close.
Wait, I know what's
Very close. Very close. No, you didn't show some of your work and it threw me off, but you're very close. Yeah. Yeah. Yes. Mm-hmm. Yes. 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 Yes, you did it wrong. Yes. 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 So for 3 pi fourths, yep. For cotangent of 3 pi fourths, we do x divided by y. And what do we notice about the x and the y? They're the same number. And one is negative. So if they're the same number and you're dividing them, you're going to get 1. And since one of them happens to be negative, you're going to get a negative 1. All right, 24. Cos. Cos of 5 pi fourths. Cos of 5 pi fourths. Cos of 5 pi fourths. Yes. Yes. Yes, 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 yes. Yes, no. Yes, yes. Yes. Yeah. Yes. Yes. All right, so we're looking at the x coordinate, which is negative root 2 over 2. All right, 25. Sine of 5 pi thirds. Sine of 5 pi thirds. Yes, yes. Close. Yes, close. Yes, yes, yes. Close. No. Yes. 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 So at 5 pi thirds, we're looking at the y coordinate, and we get negative root 3 over 2. Y coordinate, we get negative root 3 over 2. All right, 26. Tan of 7 pi over 6. Tan of 7 pi over 6. Yeah. You can use it for 10 minutes. Tan of 7 pi over 6. No.
Girl, what? Put it over one, didn't it?
No. Yes. Yes. No.
You didn't prove it right. You did cos over sine.
Close. I think. I can't tell if that's an equal sign or not. No. Yes.
Oh.
Close. Yes. 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 Close. Yes. 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 Yes.
I don't know why I thought I could divide that out. Like root 3 over 3.
Yes. 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 The negatives would cancel and make positive. I can't. All right, so for this one, if we did y divided by x, we would have negative 1/2 divided by negative root 3 over 2. And what would we do? Keep, change, flip. And what happens? The 2's cancel, and the negatives cancel, and we get 1 over the square root of 3. And you can't have a radical on the bottom.
Square root of 3.
Over 3, perfect. All right, number 27. Cos of 7 pi fourths. Cos of 7 pi fourths. Yes, 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 yes. So if we look at the x coordinate, what do we get? Root 2 over 2. All right, tangent of 3 pi halves. Tangent of 3 pi halves. Yes. Yes, yes. Yes, yes, yes. Yes, yes, yes. Yes. Yes, yes. Yes.
Okay, I might have done
Yeah.
it. Right?
Uh-huh. Yes. You didn't have to make them fractions when you wrote it out. And you didn't have to do like keep, change, flip. You could have just done the y coordinate divided by the x coordinate without fractions. And you would have got the same thing. So you made it a little bit more complicated, but you still had it.
Because I wrote it normally, where's how to get 6 over 1 sometimes.
Mm-hmm. Right. All right, so this should be undefined. All right, cover up your unit circles. No unit circle for this one.
Yeah, you're wild.
All right, cover up your unit circle. Cover up your unit circle. All right, sine. So don't look at your unit circle. Sine of pi over 6. You might have to sketch the unit circle so you can figure out where pi over 6 is. Yes. Yes.
Oh, yeah. Yes, sir.
Yes. 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 Is that a negative? Yes. No, but very close. Yes. 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 So if I picture this one on the unit circle, it's the angle that's right here, right? So if we picture the x and the y coordinate, this is one of the ones where it goes to the right a lot, up a little bit, right? Goes to the right a lot, up a little bit. And so that means it's right root 3 over 2, up 1/2. And since sine is the y coordinate, then that means this one is 1/2. Okay? So I got it by knowing my fractions and by thinking about how the numbers work, right? Okay. 30. Cos of pi fourths. Cos of pi fourths. Still can't look at your unit circle. Yes. Cos of pi fourths. Yes. 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 No. Yes. 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 Yes.
It could have been 3, so I had to put 2.
Is it at the top? It's the one, if we were to draw it, it'd be right in the middle. Yes. Yeah. So, yes. So pi fourths is the one that's right in the middle, so it goes to the right and up the exact same amount. So that's root 2 over 2 and root 2 over 2. And if we're looking at the x coordinate, that would be root 2 over 2. Pi thirds. All right, 31. Tangent of pi halves. Tangent of pi halves.
Wait. That's on the thing. That's 0. That's pi half, right?
No. Yes. 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 No. Yes. 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 Your work is wrong, but your answer's right. Yes. No. Yes. Yes. No. So, well, actually, yeah. No, yeah. You just didn't keep change flip yet.
Yeah, I was trying to figure out.
Well, it would have been 1 over 1, not 1 over 0, if you wrote it as fractions. So this point right up here, this is where pi halves is, right at the top, right? And what's the point right there? What's the point at pi halves? 0, positive 1, because it went up, right? And then if we do tan, we're going to do 1 divided by 0, which is undefined. All right, you're going to have to think about your fractions for this one. We're going to do tan of 3 pi fourths. Tan of 3 pi fourths. So think about where it would be. We got one person who got it. Yes.
It's like,
Yes.
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 Oh, yeah.
No. Yes. Where does 3 pi fourths show up? Yes. In the middle of the second quadrant. It's right over here. So if we want to figure out the point, we're going to go left the same amount and up the same amount. Left the same amount and up the same amount. Yes. So since we're going left the same amount and up the same amount, and we have y divided by x, and it's the same number divided by the same number, what do we get? We get 1, and we have a negative with it because one of them was negative. Okay, you got to picture your fractions again. We're going to do sine of 11 pi over 6. You got to think of your fractions. Sine of 11 pi over 6. Yes. 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 No. Yes. No. It's sine, so it's just the y coordinate. Yes. 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 No. Yes. All right, so if we think in terms of 6, no. 2 pi would be over here, right? No. 11 pi 6 would be where? Yes. It'd be in the 4th quadrant. Where in the 4th quadrant would it be? Very close to 2 pi. It'd be right here. So we're thinking to the right a lot, down a little bit. To the right a lot, down a little bit. So what point would that be? It'd be root 3 over 2 for the x coordinate, negative 1/2 for the y coordinate. And so this is negative 1/2. Yeah. Yeah. Yes. Okay. So on your paper, we are going to write down card number 1. So we have cos of pi over 6. We have sine of pi over 3. We have sine of 2 pi over 3. And we have cos of 5 pi over 6. All right. So what you're going to do with the cards is, without using a unit circle, you're going to figure out which one does not fit. Okay? You're going to figure out which one does not fit. Now, if you get to the point where it's been a few minutes and you're not, like, coming up with anything, you can look at your unit circle, okay? This is not a test, this is just us practicing, okay? So if we think about cos of pi over 6, what is cos of pi over 6? It's not 1/2, that's sine. It'd be root 3 over 2, right? So if we picture that one on the unit circle, that one's this little angle right here. It's right a lot, up a little bit, and cos would be right a lot. And that's why it's root 3 over 2. So that one's root 3 over 2. All right, where's pi thirds? First quadrant, but it's close to the other line, right? It's this one right here. So this one is right a little bit, up a lot. So right a little bit, up a lot, it's sine. It's root 3 over 2, it's going to be the up a lot part. Okay. Sine of 2 pi thirds, where does 2 pi thirds show up? So this over here is 0. This is 1/2. This is 1. So where would 2/3 show up? It's in the second quadrant. It's right here. So 1/3 is right here. 2/3 is right here. All right. So it'd be over a little bit, up a lot. So sine of 2π3 would be what? Left a little bit, up a lot. It'd still be √3/2 because you're still going up a lot. Okay, cos of 5π6. No. So if pi is 6/6, if pi is 6/6, then where does 5/6 show up? Right above it, but it's really close to it. Okay, so it is left a lot, up a little bit. Left a lot, up a little bit. It's negative √3/2. Okay, so which one doesn't fit? This one doesn't fit. Okay, and then we'll move on to the next card. So you can see if it gets to the point where you're struggling to figure out what it is not constructive anymore, where you're just getting frustrated, go ahead and get your unit circle out. All we're doing today is we're just practicing the unit circle. We're trying to do our best to recognize the answers and be able to start memorizing them. Does that make sense? So I'm not trying to torture you. If you get to the point where you're like, yeah, I'm not going to remember that one, just look it up real quick. Okay? All right, so you do not have to finish all the cards. You just get as far as you can without wanting to cry. Okay? All right, go ahead and work on those.